Well, let's talk about section 4.5. What this section entails is graphing all of the transformations of our sine and cosine function. Now, we know that they're periodic because all that they represent is, well, the sine is the y component values at any angle on the unit circle, and the cosine being the x component values at any point on the unit circle. So just from our basic knowledge, we know that they're going to be defined for any value of x because that's just the angle. They exist for all angles. But then their y values are going to oscillate between -1 and 1. We know that the sine function at 3 pi over 2 is going to be -1. At pi over 2, it's going to be 1. The cosine function is going to be a y value of 1 at an x value of 0 and a y value of -1 at an x value of pi. Now, so going into this, we will work on an understanding of the graph of both the sine and cosine functions and all of their variations. And then we're going to look at some word problem applications of them. So first of all, the sine function. All of these values you should know. We should know it because it's just values from our unit circle. So at all the important values on the unit circle, we should know that the sine function is, for example, at an angle of 0, it's a y value of 0. At an angle of pi over 6, it's a y value of 1/2. At an angle of pi over 3, it's a value of square root of 3 over 2. I could have stuck in pi over 4 there, but it would have made my chart too long. We know at pi over 4, it's the square root of 2 over 2. At pi over 2, it's 1. Now, you can construct a smooth curve for the sine function given that information. And you see, well, yeah, okay, it's going to start off at 0, 0. As the angle goes towards pi over 2, your sine function goes up to 1. That makes sense. But then as your angle gets into quadrant 2, it's starting off at 1, but we know it's going down, down, down. By the time it ends quadrant 2, it's at a y value of 0. Then in quadrant 3, from pi to 3 pi over 2, it's going to go from the y value of 0 down to the y value of -1. And then from 3 pi over 2 to 2 pi, it's going to go back from 0 to 1. Sorry, from a value of -1 to 0, I should say. Now, that leaves us what I would consider 5 important points on this graph. I want us to understand that the base sine function always has the ordered pair 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi comma 0. If you know those 5 points, you can always construct a nice smooth curve. Now, what we're going to do for any transformation is we're just going to think about what happens to those 5 points, because any transformation is going to be an extremely similar looking graph. Okay, now, things that we should understand. The domain of the sine function can have any angle in there. Its domain is -infinity to infinity. The range of the sine function is -1 to 1. As you can see on the previous page, it can't ever get above a value of 1 because it's simply the y component on the unit circle. It can't get below a y value of -1, again, because it's the y component on the unit circle. It never goes below where the y component is at 3 pi over 2. Now, I can say that because it's just those values, as you rotate around the unit circle and start that rotation again, of course the graph is going to start up again. So it's a periodic function with a period every 2 pi units. Every time you would rotate around the unit circle, every 2 pi radians, the graph would just begin and end again. Now, if you think about whether the graph is an even or an odd function, it becomes very quick to see. If you just graph it out here, you can see that, f of x is equal to the negative of f of -x. So this is an odd function. It's symmetric with respect to the origin. Now, whenever we're graphing sine functions, this looks like a lot on this slide, but it's really not that bad. First thing you're going to do is you're going to identify the amplitude and the period, and we'll talk about how to do that. And then you're going to find those 5 key points. That's what happens to the values when x is 0, pi over 2, pi, 3 pi over 2, and 2 pi. You're going to find what happens to every single one of those 4 points. And then you're going to find the values of y for the 5 key points. And then you're going to connect those 5 points with a smooth curve, and and you should have your graph. Now, after that, those 5 points, you know that your graph will continue on in the same pattern in a periodic nature. So if your problem asks you to graph more than one period of the function, you could continue on. For most of my problems, I won't require the step 5 here. I only want to see one period of the function. After that, you're kind of just wasting time. Now, when we look at determining the amplitude of the function 3 sine of x, well, the sine of x, the y component, it's just getting multiplied by 3. So instead of going down to -1 and up to 1, it's going to go down to -3 and up to 3. Now, the amplitude is defined as the distance from the center of the sine function to any maximum or minimum point. So in this case, the amplitude is just the absolute value of 3, because you say, well, it can go up or down 3 from your central value of 0. So the amplitude in this case is 3, which means it goes up to 3 and down to -3. Period would still be 2 pi radians, because notice your independent variable x that's inside the function, it's not getting multiplied by anything. So it's not changing. Now, notice our x values here. These are our standard x values that we always check: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, I already know, you don't have to plug them in. I already know what they are. I know that the sine function normally is 0 when x is 0. So if you multiply that by 3, it's still 0. Well, at pi over 2, the sine function would be 1. Now it's going to be 3. At pi, the sine function would be 0, still 0 when you multiply by 3. At 3 pi over 2, normally it would go down to -1. Now it's going to go down to -3. And at 2 pi, you're completing the period. It goes back to saying the same thing as the sine of 0, which is 0. You multiply that by 3, you still get a 0. So yes, you physically can plug this into the function if you like. But as you get comfortable with these problems, this middle portion should be completely unnecessary. You should just know based upon what the basic shape of the sine function looks like. So now I can say, okay, basic sine function always looks like this between 0 and 2 pi. Well, what's the difference in the basic sine function and our 3 sine of x? You just say, well, the amplitude's multiplying by 3, so it's just stretching each of those y values out by a factor of 3. I can show that right there. Now, if I were to extend this, what if my problem said, well, I don't just want it from 0 to 2 pi. I want to know what the graph looks like from -pi to 2 pi. Okay, no big deal. If instead of going from 0 to 2 pi, if I need to start at -pi, I just say, well, the sine function's cyclical, so I know that before this 0, 0, since it's going up after it, it had to be going starting off at a negative y value before it. So you would have this same region right here that would be a 2 pi period, same portion as this region right here. You say, well, it's cyclical every 2 pi periods. So what happens at 3 pi over 2, the same thing should happen at -pi over 2. And I can see that that period of 2 pi does result. And you, of course, have to keep your amplitude of 3. So you go down to -3 at -pi over 2 there. Now, the amplitudes and the periods, we already know that the amplitude is just the absolute value of whatever the coefficient of the trig function is. Now, the period, and this shouldn't be any question to us. If you think back to how we transformed functions with algebraic functions, we said that anytime something is in with the x, it does the opposite of what it looks like it does. So if I have the sine of bx and you say, ooh, that b, it's affecting it horizontally because it's impacting the x. Yes, it does impact it horizontally. How does it impact it horizontally? Do I multiply my x values by b? No. You do the opposite of what it looks like when it's in with the x. So you said, well, then you're going to divide each of your x values by b. Yes, absolutely. Okay, so if horizontally your period is normally 2 pi radians, then if the coefficient of x is b, your period now is going to be 2 pi divided by b radians. So whatever the normal period is of a trigonometric function, and for the sine function it's 2 pi radians, the period after you multiply its angle by b is going to be 2 pi over b. Now let's see that in an example. I want to look at the graph of y is equal to 2 sine of 1/2 x. Okay, now I know that this sine function is going to get stretched by a y value of 2. Its amplitude is 2, so I know its high value is going to be 2, its low value is going to be -2. Now, in addition to that, I also know its period is being affected. And I can say it looks like the x value is being multiplied by 1/2, but please remember the actual impact horizontally is you're going to divide all of the x values by 1/2. So you say the period normally would have been 2 pi radians. Now it's going to be 4 pi radians. I'd also like you to remember each of those increments that we go from 0, 0 to pi over 2, 1, down to pi 0, 3 pi over 2, -1, and 2 pi 0. Each of those increments is 1/4 of the period. So all you have to do is take that period and divide it by 4, and you'll find all of your important increments. So you say, well, what if I start at 0? What's your first increment? 1/4 of the period. So I'm going to go 0, pi, 2 pi, 3 pi, 4 pi for my 4 values. Before I even go to the next page, I am 100% certain this is going to contain the point 0, 0. It's going to contain the point pi over 2, 1. It's going to contain the point 2 pi 0, 3 pi negative. Oh, I should have said pi 2 because it's being stretched by a factor of 2. Pi, 2 pi 0, 3 pi is going to be -2, and then 4 pi is going to go back to 0. It's going to have that nice shape stretched out by a factor of 2 amongst those 4 values, 100% certain. This is just where I'm showing where those x values come from. You just say, well, every single time the increments are 1/4 of the period. The period for this function is 4 pi. Divide that by 4. Your important points are going to occur every pi radians, where normally they would occur every pi over 2 radians. So now let's find the y values for each of those x values. This is where I was saying we should know it before we do it. You can physically plug these in like I'm doing here, but it should be unnecessary. I know normally my sine function is going to go from 0 to 1, 0, -1, 0. The only thing that's happening here is it's being multiplied by a factor of 2. So any of those y values where it would normally be 1, now it's 2. Any of those where it would normally be -1, now it's -2. So you just say, okay, it's that same basic shape. And now when I look at my graph, I can say, okay, my normal sine function has this shape. The sine function I have has this shape. It's just that my x values, instead of going from 0 to pi over 2 to 2 pi to 3 pi over 2 to 4 pi, 0 to pi over 2 to pi to 3 pi over 2 to 2 pi, I'm taking each of those x increments and I'm multiplying them by 2. That should not be any surprise from the very beginning of this problem. You could have thought, well, what are your x increments of the normal sine function? Well, normally they go from 0 to 2 pi. In this case, that period is going to be satisfied by multiplying by a factor of 2, since you're dividing by 1/2 is multiplying by a factor of 2. That's why they go from 0 to 4 pi here. So you can say, and then it's being stretched by a y value of 2. That's why it goes up to 2 and down to -2 here. Now, I get my entire sine function graph, the entire period from 0 to 4 pi. This particular problem asked me to graph it on out to 8 pi. So I know I could easily continue this on out by continuing this same pattern, just like this. No problem. And you have to, of course, keep that amplitude of 2. Now, what if I have a phase shift? Anytime you're shifting a sine or cosine function horizontally, it's called a phase shift. So a horizontal shift. What we're going to be thinking of in that case is if I have the graph of a sine of bx minus c, we can say this is going to be obtained by horizontal shifting of a b or sine of bx, so that the starting point of the circle is shifted from x equals 0 to x equals c over b. Now, that c over b, that shifting needs to make sense, because you could say, well, I know that if I were just thinking about if it were the sine of x minus c, you'd say, well, what does that minus c do? You'd say, okay, it's a horizontal shift. And with horizontal shifts, you always do the opposite of what the sine would imply. So you'd say, well, that's going to shift it to the right c units. Now, why is it divided by b? Because all of the x values will be divided by b. So you say, well, that shifting to the right c units then gets divided by b because that's the coefficient of x. So you say it's going to be a phase shift of x equals c over b. Now, of course, it's to the right. Anytime you have minus c, if that would have been plus c, it'd be a shift to the left. So that number c over b is going to be called the phase shift. You could think of it as a horizontal shift. Now, in this case, let's say I ask you to determine the amplitude, period, and phase shift of y equals 3 sine of 2x minus pi over 3. Amplitude, easy. You just say it's the absolute value of the coefficient. So the amplitude is 3. Now, when I'm thinking about the period, I can say, well, the period, normally it would be 2 pi radians. This is going to be 2 pi radians divided by the coefficient of x. So, hey, it's going to finish off its period in pi radians. Now, its phase shift. This would tell me that it's going to get shifted to the right pi over 3 radians, but then that shift to the right also gets divided by 2. So I can say, well, it's going to go to the right pi over 3, then divided by 2. Well, pi over 3 divided by 2 is pi over 6 radians. This graph is going to be shifted to the right pi over 6 radians. Now, that's going to make it a little bit hard to find our 5 important points. Remember, our important x values normally are 0, pi over 2, pi, 3 pi over 2, and 2 pi. So I can say, well, okay, now those 5 points, it's got to start at pi over 6. That's where this sine function is going to start. How do I find my next important x value? Well, my next important x value is always 1/4 of a period over. And you can say, well, your period has pi radians, so 1/4 of a period is going to be pi over 4 radians. Instead of our normal increments of pi over 2, now we'll go in increments of pi over 4. So to get from the first important point to the next, I'll just say pi over 6 plus pi over 4. That's what I'm doing on this page. So I showed you that the increments in this graph, the increments are always whatever your period is, which our period in this case is pi radians, divided by 4. The important points in the unit circle is all at the 1/4 points. So I can say, well, pi over 4 instead of our normal pi over 2. So I take my first value, which this is being shifted to the right, pi over 6. So it does not start at x equals 0. It starts at pi over 6. Then I can say my second important point is going to be pi over 6 plus pi over 4. Well, that just gives me 2 pi over 12 plus 3 pi over 12 is 5 pi over 12. To get to my next one, I'd say, well, that's going to be 5 pi over 12 plus pi over 4 I know is 3 pi over 12. That'd be 8 pi over 12 or 2 pi over 3. I keep on doing this, keep on adding 3 pi over 12. When I add it again, I get 11 pi over 12. When I add it again, I get 14 pi over 12, which reduces down to 7 pi over 6. Now, on the next page, I have me evaluating each of these points. There's really no need to. I already know the y value at each of these x values. The whole point for doing this is that, I know what the y values are. What does the sine function start off at? 0. Then it would normally go to 1 at the next important point. This graph is getting multiplied by a factor of 3. So I already know I have pi over 6, 0. I'll have 5 pi over 12, comma 3. I'll have 2 pi over 3, comma 0. I'll have 11 pi over 12, comma negative 3. I'll have 7 pi over 6, comma 0. I am 100% certain of that. Now, I show it here on the next page. You can take each of these important points, plug it into your function, and you'll see you're getting the y value. Yes, 0, that's the central value. 3, that's the high y value. 0, back to the central. Down to negative 3, the lowest it can take on, and then back to 0 at the end of it. So now I can say, well, then one period of this sine function can be graphed from pi over 6 to 7 pi over 6, just like this. And then I can say, well, all right, I've got that in there, one period of the function. That looks pretty good. It's showing the amplitude goes up to -3, down to -3, and I know that the period here is pi radians. So this would be a good graph. Now, if we talk about the cosine function, very similar to the sine function. It's going to be, both of these are what's called sinusoidal functions. They're periodic and they oscillate between -1 and 1. Now the cosine function, because it's representing the x component on the unit circle, we know that at an angle of 0, it gives me an x value of 1. At an angle of pi over 2, it gives me an x value of 0. So you can see, oh, okay, my important points here are going to be 0, 1, pi over 2, 0. When it rotates to pi, your x component is -1, 3 pi over 2, 0, and 2 pi 1. So again, there's those 5 x values I'm wanting you to consider. 1, 2, 3, 4, 5. So those 5 points are the critical components of graphing your cosine function. You say, okay, graph starts off at 0, 1, then pi over 2, 0, then pi -1, 3 pi over 2, 0, back to 2 pi 1. After that, it merely repeats itself forever and ever and ever, and it repeats itself forever and ever before that value too. So now, when I'm thinking about the cosine function, I can say, well, it has an infinite domain. I can plug any angle into it I want. Its range, it always goes between -1 and 1. It has a period of 2 pi radians. It starts to repeat itself after that. Now, unlike the sine function, though, I think it's important for you to see the cosine is an even function, which means you can change the sine of an angle and it doesn't change the sine of the cosine function. Cosine of -x, same thing as the cosine of positive x. Cosine of -pi over 2, same thing as cosine of pi over 2. Cosine of -pi, same thing as the cosine of pi, and so forth. Now, sinusoidal graphs, I was saying both the sine and the cosine are sinusoidal graphs. I think it's also important for you to see, we know that the sine function starts off at the point 0, 1, and it's going to go up to 0, 0, and it's going to go up to the point pi over 2, 1, and then pi 0, 3 pi over 2, -1, 2 pi 1. Please notice with my cosine function, it starts off at 0, 1, then goes down to pi over 2, 0, and then pi, -1, 3 pi over 2, 0, and 2 pi, 1. But if I were to say, well, all right, what if you shifted that cosine function pi over 2 units to the right? You'd say, ooh, well, then that would look like the sine function. I could also say, well, what if you wanted to adjust your sine function instead of adjusting your cosine function? So I could say the sine of x is equal to the cosine of x minus pi over 2. That would be correct. But if I'm thinking of adjusting my sine function, I could say, well, how could I adjust my sine function to make it the cosine function? And all I would have to do is say, well, what if I dragged it pi over 2 radians to the left? Then you'd say, ooh, then you would have the point 0, 1. You would have the point pi over 2, 0. You'd have the point pi, -1. You'd say, hey, yeah, then that would become the cosine function. That's what I'm saying here. The cosine function is just a phase shift of pi over 2 units left of the sine function. So long story short, if you can graph one, you can graph the other because they're essentially the same graph, just a horizontal shift of one to the other. Whenever we look at the cosine function, its amplitude and period are identical to the sine function. You say its amplitude is just the absolute value of any number multiplying it. And the period is always the normal period of 2 pi radians divided by the coefficient of whatever is multiplying x. And then we can say, for an example here, what if I ask you to graph -4 cosine of pi x? So first of all, I want to get the amplitude and the period. Amplitude, does it matter that it's getting multiplied by a -4? Not in terms of the amplitude is still 4. But now I know that negative is just going to be a reflection about the x-axis. So instead of starting, normally this cosine function normally any cosine function starts off at 0, 1. This cosine function is going to start off at 0, -4, because yes, it's being multiplied by 4, but it's also being multiplied by a negative. So it's going to reflect it about the x-axis. And then you'll say, well, then this cosine function is going to have a shape starting downward, going up. It's going to have a maximum later on rather than to begin with. So I know that that is affecting the shape of the graph, but as far as the amplitude, I just say 4. Now the period is always going to be 2 pi divided by the coefficient of x. That's 2 pi over pi. So I know that this graph, the important points are going to be every 1/2 of a unit, because I would take that period, divide it by 4. 2 over 4 is 1/2. I'll go from 0 to 1/2 to 1 to 1.5 to 2 for my important 5 points on the graph. Notice that's what I'm showing on this page. You say your important points occur every 1/4 of a period, so that's every 1/2 of a unit. We know our first point is at 0 because it's not being horizontally shifted to the left or right. Then you say, well, your next point is just 1/2. Then your next point after that, 1. Then 3 over 2, and then 2. Now, on the next page, I'll show where the y values come from, but you should already know, and I know. So if you think about the cosine function, at the beginning point, it's normally 1. Well, this one's getting multiplied by -4. So I know the y value for this first x value is -4. Then what? The y value here is 0. Then what? The y value here is going to be 4. Then the y value here is 0. Then you'd say, then you're going to go to a final y value of -4, and that would complete the period. So that's all I'm showing here. You can physically plug these into the functions. Yeah, it does start off at 0, -4. Then when you plug in your next important point, you're going to get a y value of 0. Plug in your next important point, a y value of 4. So as you plug in these important points, the only y values you'll ever get is the x-intercepts and the maximum minimums, and those are going to alternate. So I know that the next one at 1.5, it's going to be a y value of 0, guaranteed. And you can see, yes, it is. What happens after that? You're going to go to the minimum this cosine function can ever take on. So at x equals 2, you have a y value at -4. Now we can see that that plotted out. This is, remember, our normal cosine function would have started here at 0, 1, went down, and then back up by the end of the period. So we say this is just being multiplied by -4. So instead of starting at +1, it starts at -4. It completes its period in 2 radians. So every 1/2 of a radian is 1/4 of a period. And we say, oh, yep, it goes from the low point to an x-intercept to a high point to an x-intercept to a low point. And now if they had you graph anything else, like in this one, if I had to do 2 periods, well, I could go ahead and draw from -4 to 4. It's just going to, sorry, from -2 to 2. The region from -2 to 0 is going to look the exact same thing as the region from 0 to 2. Now, what if I have a phase shift? No problem. You say any phase shift is just whenever you're adding or subtracting inside the angle of the trig function, and it's the opposite of what the sine. So if you see a minus, it's being shifted to the right. If you see a plus, it's being shifted to the left. And it's always that horizontal shift divided by the coefficient of x. So you'll see if it's bx minus c, that's telling you it's a shift to the right, c over b units. Now, what if I have asked you to graph the function y equals 3 over 2 cosine of 2x plus pi? So you can say, okay, there's 3 things going on here. The amplitude, this cosine function is being multiplied by 3 over 2. So I know it's going to start at its initial point of 3 over 2, then it's going to go to 0, then it's going to go to -3 over 2, then to 0, then back to +3 over 2. I am certain those will be the 5 y values throughout the problem, or the y values at the 5 important points. Now the goal is, well, how do I find those important points? This one's being has a phase shift, and we know it's being shifted to the left. Since it's plus pi, it's being shifted to the left pi units. But then you're going to take all of your x values and divide them by 2. So I really say, well, it's being shifted to the left pi over 2 units. So the phase shift there, you'll see I have negative pi over 2 for the phase shift. That'll be my starting point. Now, the period is also being reduced because we can say, well, normally our period for the cosine function takes 2 pi radians. This one is going to be 2 pi divided by the coefficient of x2. It's going to finish up its period in pi radians. So I automatically know this cosine function is going to start at negative pi over 2. It's going to end at pi over 2. It's going to have all 5 important points in that region from negative pi over 2 to pi over 2. Now, what are the 5 important x values? This one right here, that's your first one. How do you get your second one? Remember, please remember, your important points occur every 1/4 of a period. So you say, well, 1/4 of a period here is pi over 4. I think of this as negative 2 pi over 4. My next one is going to be at negative 1 pi over 4. Then at 0. Then at pi over 4. And then at pi over 2. That's what I'm showing on this page. The period divided by 4 shows you your increments between each important x value. And then you can say, okay, they go in increments of pi over 4, where my very first one is negative pi over 2. So my next one is negative pi over 4, and then 0, and pi over 4, and pi over 2. Now, do I already know what their y values are at each one of these? Yes, and I want you to know that as well. I show me plugging them in on the next page, but I should know it even without that. Just because of my knowledge of the cosine function, I would say, well, at the starting point, the cosine function usually starts off at a y value of 0. What is this one going to start off at? And I'd say, well, this one is going to start off at a y value of 3 over 2. So I can say at negative pi over 2, I know my y value is 3 over 2. Then at the next important point, negative pi over 4, it's going to go to 0. Then I can say, well, then it's going to have the point x, the next important point, 0, it's going to have the y value negative 3 pi over 2. Then it'll go back up to an x-intercept at pi over 4, and then it'll go back up to the maximum y value of 3 pi over 2 at pi over 2. I know that's the case. This shows it. So you evaluate your first point, no surprise, you're going to get the maximum y value. You evaluate your next important point, no surprise, you get the x-intercept. You evaluate your next point, no surprise, you get your minimum y value. You evaluate the next important point, you get an x-intercept. Now, your fifth and final important point, we should already know before I go to that next page. You should know, hey, at pi over 2, it's going to be positive 3 over 2, isn't it, John? You bet. Yes, gorgeous. So can you show it out, do all of this work, and figure it out? You can if you have to. But I'd rather you just say, hey, I know what the base shape of the cosine function is. I know I'm going to adapt the x values to make me give those y values the maximum minimums and the x-intercepts. So I can just use that instead of having to physically plug it in each time. These problems could take a long time if you want to show out all of this work. You can, but you don't have to. So now when I'm thinking of connecting the 5 key points on the cosine function, I can just say, well, I know that my graph started at negative pi over 2, 3 over 2, went to pi over 4, 0, went to 0, negative 3 over 2, pi over 4, 0, and then pi over 2, comma, 3 over 2. So I get that in there showing the period of pi. If I had to graph that any further, I could have went ahead and kept on with that period shape forever and ever and ever if I had to. But typically, I only want one period anyway. Now, let's look at an application problem. This problem, and there's a problem at the end of the homework assignment similar to this. It's not, this one's actually harder because the one in the homework gives you the function and asks you to do something with that function. This one is giving you information and asking you to set up a function based on that information. A little bit more difficult in that route. So this is just saying, hey, if you're 30 degrees north of the equator, you're going to average 10 hours of daylight in December. That's when it's the least amount of daylight in the year. And the maximum hours of daylight are in June. Okay, so when I'm thinking about that, it says let X represent the month of the year, and with one for January, 2 for February, 3 for March, and so forth. Okay, so I know January, February, March, April, May, June. June, the 6th month of the year, is when the maximum occurs. All right, I'm going to keep that in mind. And 12, the minimum of the year, December is when the minimum occurs. So I want a sine function to model in which x equals 12 is going to give me x equals 6 is my maximum and x equals 12 is my minimum. Now, because the number of hours of daylight range from a minimum of 10 to a maximum of 14, we know that this curve is going to oscillate from 10 to 14, which means the central value has to be 12. That's thought of as our x-axis, except it's just being shifted upward 12 units. You say, well, it's going to be 12 plus or minus 2. And so now we can say, then that amplitude of my sine function has to be 2. And absolutely it does. Now, maximum hours of daylight is 12, which is 2 hours more than 12 hours. Thus, the amplitude is 2. Now, the cycle. I know that it needs to complete the entire cycle of how much sunlight we're going to get over the 12 months of the year. So I go ahead and say, well, then my entire period has to be 12. Well, my entire period formula typically is 2 pi over whatever the coefficient of x is. And I'm trying to find out what A, B, C, and D are in this formula. Now, I already know what A is, and I know what D is. D is going to be 12 because it's the midpoint in between 10 and 14. A is 2 because we're going down 2 and up 2. Now I need to find that. Well, I can find it. So I know that it takes 12 months for the entire period. The period for a sine function normally is 2 pi. So we say, well, 2 pi over b has to equal 12. That's the actual period of this function. If I multiply by b on both sides, I get 12b is 2 pi. Thus, b is going to be 2 pi over 12 or pi over 6. So now I know that the coefficient of x in this formula has to be pi over 6 to ensure that the period of this sine function stops at 12 months of the year. So I can say, okay, now what's up next? I can say, because we are using the sine function, we start with a middle value. And when you think the middle value, why are we starting with the middle value? Think of the graph of the sine function. Starts off at 0, 0, then it goes to a maximum of pi over 2, 1. Then it goes down to a value of pi 0, then 3 pi over 2, negative 1, and then 2 pi 0. So when I'm thinking about that, I can say, well, all right, I know that the maximum amount of sun was going to be in in June, which we already said was the 6th month. And the minimum was 6 months later in December, which is the 12th month. So if you think, well, then that means every 3 months should be a critical portion of our graph. We're going to say, well, at 6 months, it had the maximum. If you go to a quarter of a period before that, please remember your 5 important points are always a quarter of a period away from one another. So if we have a maximum at 6 months and it's 14 hours, then we're going to have a middle value, a middle y value in this case is 12 hours. You're going to have 12 hours of sunlight a quarter of a year before June. So that would be in the 3rd month, March. You could also think of it the way I have it written here. We have a minimum in December. So you go from a low of December, 1/4 of a period later, you would hit the x-intercept, or in this case, it's the middle value of 12. So you have a minimum of 10 hours in December. 3 months later, January, February, March, 3 months later, you're going to have 10 hours. So I know that the starting point, since my sine function usually starts at 0, 0, I need my starting point here to be March. And then that will enable 3 months later, June, to be my maximum where I get 14 hours of sunlight. So I can say, okay, what is all of that telling me? Well, it's telling me that I need to let my phase shift 3 equal C over B. And then that tells me that in this case, in order for my phase shift, in order for it to be shifted 3 months over for my starting point to be 3, I let that equal C over B. I already know the coefficient of X is pi over 6. Multiply by that on both sides, and I get C is equal to pi over 2. Now, that tells me that my general equation, I already knew that my amplitude was 2. I knew that the middle value was 12, and then we're going up 2 and down 2 from that. I knew that my coefficient of X had to be pi over 6 to ensure that this finished the period in 12 months. And then in order to ensure that my starting point could be March, which enabled the maximum value to occur 3 months later in June, and the minimum value to occur 3 months before in December, that had to give me C is equal to pi over 2 in order to enable that. Now, please notice, if you took your C over B, that's telling you, yes, it's being shifted 3 months to the right to get to your final problem. That's a gorgeous problem. It's tough. I think the problems in your homework assignment you'll think are easier because it's going to give you the function and ask you information from it. Okay, guys, I'll stop with that in this section. This section will take some getting used to, but I think once you do, you'll think it's pretty easy. Let me know if you have any questions. I'm glad to help.